Hello friends, I Deepak Prajapati welcome you in lecture number 3 on binomial distribution. In previous lectures we have discussed what is binomial distribution and we have done one example, that how to calculate probabilities when your problem is suitable to binomial distribution. So today also we are going to discuss some more examples on binomial distribution. So let us start with this example number 3. If 15 dates are selected at random, what is the probability of getting 2 Sundays? So in this problem, the random experiment is to select 15 dates, and for each date there are possibilities that whether that selected date or whether there is a Sunday on that selected date or there is not a Sunday on that selected date. So from this question we can have the idea that how to define the random variable. So we are asked to find out the probability of getting 2 Sundays. So that indicates that we will define the random variable capital X to be number of Sundays among these 15 selected dates. And because we want to check for 15 dates, we can say that number of trials is n equal to 15. And random variable is defined as the number of Sundays out of selected 15 dates. So for each date we will check whether there is a Sunday on that selected date or not. So there are possibilities that there is no Sunday on any date. So possible value of X is 0. Similarly, there are possibilities that there will be Sunday on one selected date or two selected date and so on up to 15 selected dates. So the possible values of random variable are 0, 1, 2 up to 15. And suppose success is there is a Sunday on selected date. Okay, so this we can decide from this random variable. Random variable is number of Sundays out of selected 15 dates. That means success is whether there is a Sunday on the selected date or not. So the probability of getting Sunday is success and probability of not getting Sunday is failure. And the probability of getting Sunday on a particular date is 1 by 7 because there is only one Sunday in a week. So we can say that probability of getting Sunday is 1 by 7. So this from this information we can say that capital X is a binomial random variable with number of trials equal to 15 and probability of success is 1 by 7. Therefore, the probability of X Sundays or X successes among 15 dates is given by this probability mass function 15cx 1 by 7 raised to x into 1 minus 1 by 7 raised to 15 minus x, and x can take the values 0, 1, 2 up to 15. We are interested in the probability of getting 2 Sundays. So we put x equal to 2 here and we obtain this one 15c2 1 by 7 square 1 minus 1 by 7 that is 6 by 7 raised to 15 minus 2 that is 13. And after doing calculations we obtain the required probability to be 0.2889. Okay, so this is also example in which we can use binomial distribution formula to find out the required probability. Next example, 10 coins are thrown simultaneously. Find the probability of getting at least 7 heads. So here the random experiment is tossing of 10 coins. So number of trials is n equal to 10. And we are asked to find the probability of getting at least 7 heads. So the random variable will be defined as number of heads among these 10 tosses of a coin. So if we toss a coin, there are two possibilities. Either we get head or tail. So here probability is required for getting at least 7 heads. So we will define random variable to be number of heads among 10 tosses of a coin, and the success will be defined as getting a head. So here I have written random experiment is tossing of 10 coins. So n equal to 10. Capital X is the number of heads in tossing 10 coins. So the possible values of random variable x are 0, 1, 2 up to 10. Success is getting head. So we know that the probability of head is 1 by 2, and which is constant for each trial. So x is a binomial random variable with n equal to 10 and p equal to 1 by 2. So therefore the probability of x successes in n equal to 10 trials can be given by this probability mass function. So this is the probability mass function of a binomial random variable for small n and small p parameters. So here n is 10 and p is 1 by 2. Okay, so we put these values here and we obtain this 10cx 1 by 2 raised to x into 1 minus 1 by 2, that is 1 by 2 raised to 10 minus x. And this we can rewrite as 1 by 2 to the power x plus 10 minus x. So x will cancel out and we obtain 10cx 1 by 2 raised to 10. So probability of this event, capital X equal to small x, that is probability of x heads among n equal to 10 tosses of a coin, is given by 1 upon 2 raised to 10, 10cx. X can take the values 0, 1, 2 up to 10. And 2 raised to 10 is nothing but 1024. Okay, so finally we obtain this formula for probability mass function for a given random variable. Now we are asked to find out probability of getting at least 7 heads. That is nothing but probability that capital X is greater than or equal to 7. And possible values of x are 0, 1, 2 up to 10. So probability that x is greater than or equal to 7 means we have to go up to 10 starting from x equal to 7. So probability that x equal to 7 plus x equal to 8 plus probability that x equal to 9 plus probability that x equal to 10. And those probabilities can be calculated using this. If we put x equal to 7, we obtain 10c7 by 1024. For x equal to 8, it is 10c8 divided by 1024. Okay, so 1 upon 1024 is common, and we can write 10c7 plus 10c8 plus 10c9 plus 10c10. This you can calculate using scientific calculator or the formula of combination. NCR is given by n factorial divided by r factorial into n minus r factorial. Okay, so using this formula you can calculate this, or you can use scientific calculator to directly obtain these values. Okay, so after simplifying, this is the required probability, 0.1719. One more example. Suppose that 20% of all copies of a particular textbook fail a certain binding strength test. Let capital X denote the number among 15 randomly selected copies that fail the test. find the probability that at most 8 fail the test, and find the probability that exactly 8 fail the test. So here random experiment is to examine 15 randomly selected copies for certain binding strength test. So if we select any particular copy, then there are two possibilities. That copy of textbook will pass the binding strength test, or it will fail the binding strength test. Now here random variable is number of copies that fail the test. So we will consider success as the copy which fail the test. So success is the event that we will decided by the definition of random variable. So here random variable is number of copies that fail the test. So we define success to be the event that a textbook fail the test. Selected textbook fails the binding strength test, that is success. And it is given that 20% of all copies of a particular textbook fail a certain binding strength test. So this percentage is for failure of a test. So for each copy, the probability that copy will fail this binding strength test is 20%, that is 20 divided by 100, that is 0.2. So if we define success to be the event that textbook fails the test, then probability of success is 0.2. And random variable is number of copies that fail the test. So you can see this problem is of binomial distribution, because there are n equal to 15 copies. So number of trials is finite, and for each trial we are examining the selected copy of textbook for binding strength test. So there are only two possibilities: either the copy will pass this test, or copy of textbook will fail the test. So there are only two possibilities. Now if we define success as the event that textbook fails the test, then it is given that probability of success is constant, 0.2, for each 15 selected copies. So probability of success remains constant. And also it is clear that if we consider one copy for a binding strength test, then it does not depend on the remaining copies. So the trials are independent. So this in this problem all the conditions of binomial distribution are satisfied. So we can use the probability mass function formula of binomial distribution. So here we have to calculate these two probabilities. First we see random experiment is to check 15 copies of textbook for binding strength test. So number of trials is n equal to 15. Random variable is given to be the number of copies that fail the binding strength test. So the possible values of small x are, because n is 15, x is from 0, 1 to up to 15. These are the possible values of the number of copies that fail the test. And success is the event that copy of textbook fails the test. So it is given that probability of this copy of textbook failing the test is 20%, that is 0.2. So probability of success is 0.2, which is same for each copy. So therefore capital X is a binomial random variable with n equal to 15 and p equal to 0.2. So therefore the probability of x successes in n trials is ncx p raised to x 1 minus p raised to n minus x, x equal to 0, 1 to n. So here n is 15 and x is and p is 0.2. So we put n equal to 15 and p equal to 0.2 in this formula. So we obtain that probability that capital X equal to small x is 15cx 0.2 raised to x into 1 minus 0.2, that is 0.8 raised to 15 minus x. X is from 0, 1 to 15. Now first probability we have to find out is probability that at most 8 copies fail the test. At most 8 means x is less than or equal to 8. So now this we can do in two ways. Either we can use this formula for probability mass function. Suppose we want to use this formula, then we have to calculate up to x equal to 8. This is cumulative probability, so we have to start from probability that x equal to 0 plus probability that x equal to 1 and so on up to probability that capital X equal to 8. So we have to calculate total 1 to 8 and this one is 0. So there are total 9 probabilities we have to calculate if we are going by this formula. We have to use this formula for x equal to 0, x equal to 1 up to x equal to 8. Another way is using binomial table. So if we use binomial table for this, then it will be very easy. It will save our time. So here in this experiment, n is 15 and p is 0.2. And we are interested in this event, capital X is less than or equal to 8. So we will consider small x equal to 8. So we will check the table for these three values, n equal to 15, x equal to 8 and p equal to 0.2. So n is 15, p equal to 0.2 and x equal to 8. So you can see these are the cumulative binomial probabilities. We have n equal to 15, x equal to 8 and p equal to 0.2 means this column. Okay, so the column corresponding to 0.2 is this one and the row corresponding to x equal to 8 is this one. So we have to find out the intersecting point of these two lines. So you can see this is the intersecting point. So and all these are cumulative probabilities. These are the values of cumulative probabilities. Capital X is less than or equal to small x. And so we are calculating probability that capital X is less than or equal to 8. So it is nothing but 0.999. Okay, so intersection of this row and this column. So this is the value which is required. Okay, so using table we can quickly find out this probability. So probability that x is less than or equal to 8 is entry in x equal to 8 row and p equal to 0.2 column of the n equal to 15 binomial table, and that we see that it is 0.999. Next one is probability that exactly 8 copies fail the test. So that we can find using this formula. We can put x equal to 8. Suppose we use that formula. Probability that capital X equal to 8. So it is nothing but 15cx 0.2 raised to x. So x is 8, so 15c8. And 0.2 raised to x, that is 0.2 raised to 8, and 0.8 raised to n minus x. Here we put x equal to 8. So 0.8 raised to 15 minus 8, that is 7. So 0.8 raised to 7. And using calculator you can find out this value. Okay, but I have not gone in this way. This is I have done this using table. So we know that probability that x equal to 8 can be written as difference between these two cumulative probabilities. Probability that x is less than or equal to 8 minus probability that x is less than or equal to 7. Okay. So for this we use this one. Probability that x is less than or equal to 8 is 0.999 that we just find using binomial table, and we have to find out this using binomial table. Okay, so we have to check in x equal to 7 row and p equal to 0.2 column, and number of trials is 15. So for this we use this table with x equal to 7, n equal to 15 and p equal to 0.2. Okay, so again instead of 0.2 now p is 0.1 and x is 8. Okay, so we have to check, p is 0.2, so we are in this column, p equal to 0.2, column is same, but instead of x equal to 8 we have x equal to 7, so we have to check for this row. Okay, because x is 7, n and p are same, x is 7, p is 0.2 and n is 15. So you can see intersection is 0.996. So x equal to 7 row, p equal to 0.2 column, under n equal to 15. So the corresponding value is 0.996. Okay, we obtain that probability that capital X is less than or equal to 7 is 0.996, this one. Okay, so that we put here and we find that probability is 0.003. So it is your choice, either you can use this formula or you can go by probability tables also. But in some university exams, tables are not provided for binomial distribution. They provide the tables for normal distribution only. So in that case you have to go by this formula for probability mass function. Okay. But if they are not providing table, then number of trials will be small, so you will not have any problem in calculations. Okay, so I hope you like this lecture. In the next lecture we will discuss about mean and variance of a binomial distribution. Thank you very much.